Everyone who has just arrived, and thanks for coming along to the Processing and Analysing Data session this morning. Our second speaker this morning is Justin Baker. Justin is the manager of CSIRO's Visualisation and Collaboration team as part of the e-research program, and he will be talking this morning about CSIRO Visualisation Service Assessment and Future Plans. Thank you, Justin.
Thanks, Bernie. I've been having a bit of a fight with a cough for a few weeks, so you'll have to excuse me if I stand sideways and have a minor coughing attack. So I'm Justin Baker with CSIRO's e-research program, and I'll be talking a little bit about the overall visualisation service, what we've been doing, what's worked well, what hasn't, and some future directions. So the e-research program supports the science workflow through various systems, services and infrastructure. I won't go through the whole e-research program. There's actually a brochure was provided in the satchels, and there was a talk given on it yesterday. And we've got a booth with a whole lot of people who can, including myself, who are happy to talk about that in more detail. But for the purposes of this talk, I think the major point I wanted to emphasise was that visualisation was recognised at the start of as a key enabling technology for our e-research program. So in terms of the capabilities that the service delivers, I'll go through most of these in detail and talk a bit more about what they are and, as I said, what we're doing, what's worked and so on. So we've got tiled displays, remote visualisation, a stereoscopic display capability, a visualisation application support service, which is relatively new, access to a whole range of visualisation software, and also facilitated access to partner systems. So tiled displays were the first thing we decided to tackle. And the main reason for that was that CSIRO has a couple of large OptiPortals, and it seemed like a fairly logical place to start. So in terms of the kind of things you might do with tiled displays, I guess most people would probably come up with a fairly similar list. The most obvious one seems to be large-scale visualisation, so very high-resolution data sets. Remote sensing is probably the main example there, or astronomical data. Another obvious one, I guess, is looking at multiple data sets at the one time. So these could be similar, so you might want to eyeball, say, many graphs, similar graphs, and see if you can pick out the differences. But it could also be disparate data, but you're trying to look for connections between the two. Another idea we had was a kind of portable visualisation lab, so researchers might come and borrow the equipment in some sense and use it for a particular period of time. As an endpoint for collaborative viewing. I'll talk a bit more about that a bit later on. And the idea that I like is as a moving poster, something that you might bring along to a conference like this and have some sort of animations or changing imagery or whatever on. Interestingly, I used to see things like these poster ideas, I noticed, at conferences going back a few years, but they seem to have disappeared more recently. So with the tiled displays, as I said, there were some interesting technical issues with the OptiPortals, mostly fairly complicated to get your own software up and running on an OptiPortal. So what we looked at initially was deploying a number of smaller tiled displays instead as a alternative to that. So we had an internal expression of interest that was promoted through various channels inside CSIRO. And as a part of that, what we emphasised was the collaboration side, so that rather than just researchers needing one or some of these units to look at high-resolution data, the idea was that they would use it to collaborate with CSIRO colleagues somewhere else in the organisation. So we received 5 responses from various groups across different areas, so genomics, environmental modelling, materials and human factors, so a good mix of disciplines. And in terms of commonalities, probably no great surprise, looking at large data sets, collaboration, which was part of the initial requirement, so it's probably no surprise that's there. And also everybody actually had some sort of requirement for video conferencing along with that. And ultimately we ended up deploying 12 units across CSIRO sites in Australia, which you can see on the little map on the bottom there. So in terms of usage, we've got, I guess, 3 or 4 main groups that use these things fairly regularly, which has been very good for us. So genome sequence alignment's been quite a good one because you end up with very large DNA sequences, and it's very useful to eyeball, I guess, the sequences and even do some sort of manual alignment. So that's been the most recent one. Remote CT, computerised tomography. There's a very active group down in Clayton in Melbourne who do a lot of CT work, and then they like to collaborate in real time around volumetric data sets with their colleagues in different locations in CSIRO. And they use a whole range of tools. Evo Extract is their own internal volumetric analysis tool, Drishti and Aviso. But they also, when they're working collaboratively, they pull up various data sets in 2D and 3D, and they discuss these with researchers at other sites. And the last one there is virtual mining, and I think that's a project that's still underway, but the idea there is to share mining-based data sets with other researchers and look at different ways of interacting with that data in novel ways. And the data can be from a whole range of sources, so geoscience data, X-ray, micro-CT and so on. So even though they've been good, we've had relatively limited uptake overall, as I said before. And there could be a number of reasons for that. One thing I've noticed is early on we were giving presentations at CSIRO sites to introduce these systems, and there was a lot of excitement, and I thought this was great, so we'll have no problem with people using these. But unfortunately the initial enthusiasm didn't really translate into usage, and I guess researchers in a lot of cases were keen to see what was going on and then went back to their desks. That was perhaps the end of it, after expressing some initial idea that might be useful to them. I think the main one is the lack of portability, or where we ended up installing the systems has been a problem for us. So there's a bit of a trade-off. The higher the resolution of the system, the less portable it is. And then I guess if it's not, as I've got there, if it's not on the scientist's desk, it often seems to be too far away. One problem we had, we were looking at we did install a lot of these things in meeting rooms at various locations, which seemed to be a good idea, but then the meeting rooms themselves are relatively well used, so we were competing with general standard meetings in the meeting rooms as well as people getting access to the units. So that didn't turn out to be such a good idea. And there are a few minor usability issues. With this first iteration of these screens, they've got relatively large bezels, which initially interferes with the sort of viewing experience, although I think that goes away after a while. But something that's a bit frustrating is that the dialog boxes often hide under the bezels, and you have to become a bit of an expert at fishing them out. And also the way we put together the system in the first instance was relatively complex. You had to use Evo and VNC and be across a bit of Linux as well. If that wasn't natural to you, that could be a bit difficult as well. So this time around what we're doing is looking at a much lighter weight unit. There's a picture of one of these new units here. So smaller, lighter systems, and rather than putting them in meeting rooms, as I said, which wasn't wildly successful, they'll be located in specific work areas or even in researchers' offices because they're small enough to go on a desk. The newer generation of monitors have much thinner bezels, so this problem with the dialog boxes disappearing should go away to some extent. And in terms of complexity, we've tried a few different ideas, and it seems in the end everybody can drive a Windows PC, and these are mostly just like very large Windows PCs with multiple screens. So certainly that's a lot easier to use. We're also looking at some other ideas, like maybe controlling some of these units with iPads, some sort of software on an iPad, or maybe some gesture-based system like Connect. And also we've been working, rather than just delivering the units and saying that they were available to a whole group, we've been working with specific groups to see how they use the units and how we can work with them. And an example there is one of the units in Perth, instead of being horizontal, has been set up vertically, which more closely matches most of the remote sensing data for the state. So the next capability, which has definitely been the most successful one we've deployed so far, is remote visualisation, which is virtualised access to graphics hardware. And there are a number of significant advantages to remote vis. The main one, I guess, is that you don't need to install multiple workstations around the place. It's a much more efficient way of sharing hardware resources. They can be kept in the server room, and they're better managed by a centralised group. By definition, remote visualisation is transparent to the application. VNC, which is what we're using as the client, certainly for the Linux case, gives you this sort of free shared remote collaborative capability, so you can share your sessions with one or more users and they can get in and interact together. An obvious and fairly important case as well is that remote visualisation, you don't need to transfer large volumes of data around. You can generate the data and visualise the data in the same place, so you're not pushing big data sets around. It's kind of cross-platform as well, in the sense that if you're on a Windows machine, you can fire up one of these clients and it gives you access, say, to Linux applications, which is potentially very handy. The system we're using runs across fairly low bandwidth networks. We have done demonstrations in similar venues to this, and it's worked pretty well. It also supports true stereoscopic visualisation, and more recently we've been playing around using the devices like iPads as clients, and that works quite well as well. So in terms of the technology, on the Linux side we're using VirtualGL, which is an open source project to provide remote viz for OpenGL applications. As I said, it's got this shared remote collaborative viewing capability. It gives you this kind of cross-platform access to software. And I haven't got it there, but I should have mentioned it. You can also have multiple users sharing one GPU, which is potentially very handy if you've got a large number of users. On the Windows side, we actually tried a few different technologies and ended up settling on Citrix, which seems to work relatively well as well. A potential expensive limitation there at the moment is the requirement for one GPU per remote Windows session. So there's just a little simplified diagram here showing the way the visualization clusters work. So the circle in the middle, you can imagine, is somebody who's just logged on their own. They've jumped on to the system and they're accessing a GPU on one of the nodes, and they might be running, say, some large memory visualization job or doing some other complex work. And then the ellipse over here on the left-hand side, you could have two people on, say, PCs or similar devices interacting in some way. They could be talking on the phone as well, or have a video conferencing session going and sharing some sort of data set, interacting with it together. And then the bottom one there I think is kind of interesting. You don't necessarily need to have the same sort of endpoint, so you could have one person on a PC and another person on sitting in front of a tiled display, or a group of people on a tiled display, and that works quite well as well. So in terms of examples, we've got people doing computational fluid dynamics using some of our remote viz systems, using Maya and Insights. Got a few users of ParaView looking at very large data sets with that. Leapfrog, I think, is being used, I hadn't heard of that before, but to look at some rock face imagery of various sorts, and I think try and understand the stresses in the rocks. And some volumetric tools like Drishti and Aviso for looking at computerised tomography data. And Cytoscape, which is like a network analysis tool. And the guys in the bottom corner there proudly standing in front of a tiled display which is running Cytoscape. I think that's showing like a gene flow regulation map of some kind. So remote viz has been pretty successful for us and probably continue to grow over time. A few interesting issues, probably not just restricted to remote visualization, but what we're looking at now is integrating the remote viz hardware with some of our HPC systems. And I guess a sort of obvious point there is HPC is primarily batch-based, whereas Viz is almost always interactive. I guess you could be doing offline rendering or something as well. But we need to have a think about what's the best way of doing that and what's sensible and what works for people. Another one we've seen with a few people is this desire to have their own system to see, you know, flashing lights under their desk or whatever, which they don't get to see when the system's remote from where they are. On the software licensing side, things can get a little bit complicated, but once again, that's shared systems is probably a similar issue there. The requirement for a single GPU for each Windows virtual machine, as I said, is potentially a problem. And shared, because you're sharing all the hardware inside a visualization node, there's a potential bottleneck there with the CPU and the GPU and I/O contention as well. That hasn't actually been so much of a problem for us, but I could see it could be an issue over time. And on the security side, I think with virtual GL in particular, there's some potential to, if you knew what you were doing or even inadvertently, you could probably get access to other users' 3D or graphics imagery. But once again, we haven't really had any issues with that. So something else we were interested in trialling was having these stereoscopic display kits, so providing the researchers with a way of actually looking at their data in true 3D. And so from around about July last year, we put together little kits that the researchers could borrow. And it was either projector-based or used a 3D LCD type screen with a high-performance laptop and some glasses. Or the other option there was that we put together specifications. We've got an internal product catalogue, so we made that available to researchers who might be interested in upgrading their own desktop PCs. And we also, CSIRO are partners in the 3D Alive immersive visualisation facility at Monash Uni, which is also stereoscopic capability. And I'd have to say in our case, in both instances, we haven't had much success with either of those. Had a few groups express interest for things like conferences. I think there was an astronomy conference last year where one of these was used for showing galaxy formation. But I wouldn't describe the fact we haven't really got people clamouring or knocking on our door to get access to these units. But I'm hoping that'll change over time now that we've got this visualisation application support capability in place. So as the name implies, that's targeted support specifically for visualisation applications and data. And it seems to me, I've had a chat at one time or another with the managers of most of the Viz labs around the country, and that's something that's a standard offering in most cases. And probably more useful than just providing the infrastructure is actually having someone working alongside researchers to do this kind of work. So we've got a small number of projects there at the moment that we've got underway, and this I guess this list will grow over time. The group's growing. We're actually advertising for another person at the moment. But some of these projects are actually quite interesting. I can see Jonathan hiding down the back there. He's working on a bushfire simulation project, and I think the idea with that one is to actually calculate the heat intensity on buildings as a bushfire front moves through a certain area. And some others we're looking at different ways of representing multi-dimensional materials data sets, which are potentially complicated. In fact, I went to a talk the other day about exactly that, coincidentally, and one of the people was talking about using audio as well as a mechanism, so you can visualise stuff up to about 9 or 10 dimensions, he was saying, and then maybe get into using sounds as a way of looking, perceiving the other dimensions. Anyway, the idea of these projects is to provide short-term, sort of highly focused support. And as an example there, I've got, say, dedicating half a person over a 3-month period. And some, I guess, considerations, things to think about on the application support side. It's not entirely clear what the boundaries are. So if somebody comes to us with a very complicated spreadsheet and they want to do some sort of charting or analysis, is that visualisation? Does that necessitate application support? And obviously at the other end, it could be somebody with complex data that they'd like to render or visualise in 3D, stereoscopic. Another problem we've had is very rubbery scope. So we'll have discussions with the researchers. We think we walk away with a clear idea of what's required, and then at the next meeting we find we've both got completely different ideas of what they're after versus what we thought we were delivering. Probably not strictly limited to this area. Researchers' time, getting access to the researchers has been a bit tricky as well, so that often happy to meet in the first instance and explain what they're after, and they disappear into the woodwork and can be hard to get hold of again. Now, gaining appropriate approval is something I find interesting because it's sometimes hard to gauge whether what we're involved in, these visualisation projects, have some relevance and importance within a given business unit in CSIRO, or they're just some researcher whim, so we need to be a bit careful and try and tease it out a bit. And like any good project management exercise, we need to be careful with prioritisation of projects and allocation of resources and so on. And the last one that I've got is the outreach side. It's actually not that easy to necessarily to explain what this exercise is and to make it known across the whole organisation, and then to get people willingly to come back and contact us if they think they need this sort of assistance. So that's the end of the presentation. And I'll just mention as well, as I said, we've got our booth up in the exhibition area if anybody's interested in coming by. So there are a few demonstrations. We've got some visualisations, some various researchers in CSIRO. And then there's some movies talking about some of our other capabilities, and we can demonstrate some of these other tools as well. So if they're of interest, please come by and see us. Okay, thank you.
Thank you very much, Justin. Does anybody have any questions they'd like to ask Justin about his talk? If you'd just like to speak at the microphone, please. And if possible, introduce yourself and your affiliation as well.
Kaylee Waterford from Intersect. When you say 10 dimensions, do you mean just 10 layers or?
So it would be data with, say, 10 attributes.
Okay.
And they're all potentially interrelated, but it's not clear at the outset what the relationships are.
Okay. Fascinating.
Any further questions? Anyone else have a question? Yes.
Hi, it's George Beckett from IVEC. I was interested in the sort of targeted work you do with specific groups, and I wondered how you chose those groups. Do you go through some kind of selection process or application process?
In the first instance, we've been fairly informal with that. So we have, friends and colleagues around the place that are in need of assistance. And so that's where I think most of the first list of projects came from. But we will formalise, have another expression of interest, and that'll be promoted internally. We do a similar thing. We've got an accelerated computing program which you probably know a bit about, to sort of optimise and parallelise people's code and so on. And that's normally done through an expression of interest, and we'll probably even join in with that. So seek interest through that mechanism.
Great. Thanks very much.
Mark from Griffith. You've mentioned that remote viz is something that struck you as being popular. Have you had much interest for generic web-delivered remote visualization capabilities as opposed to dedicated apps?
No, not really. No.
Well, that's closely ties into that question. What kind of uptake have you had with the visualization cluster, and did you get to a situation where actually you need to do reservations on individual nodes?
We've got a few. These things have sort of grown slightly historically because we've tried out a few prototypes and we're still looking at a few different things. But we've probably got, I'd say, representing about 8 or 10 different groups, research groups, and say about 30 different researchers fairly actively using the systems. And as it's promoted over time, as I say, there doesn't seem to be any shortage of customers for that. And once, I'm assuming that HPC integration I'm talking about as well will sort of open up that capability to a whole load of new users as well.
Okay, that's I think all the time we have for Justin. So thank you everybody, and thank you Justin very much.
Okay, thank you.